We're going to start with number 9 here, folks, and then we'll go on to 11 and 7. 9, very similar to one, I think it's to either 10 or 6. I remember doing it in B block. But, alright, so it's saying what speed must the painting move parallel to its width that is to appear to be square? Express your answer in terms of the speed of light of c. So one thing I always think of when they say express in terms of c, I think of solving for v over c rather than just for v. Remember, ladies, you don't have to pay attention, but just kind of keep it down. All right. So let's do the y first here for number 9, which would be how about the length, which is the dimension in direction of travel, contracts when in motion. I think that's the point that would need to be in there. And then, how about only the length changes? So, the new length is less than the rest length. And the last one, the speed of light is constant in all frames of reference. I think that covers all the concepts and ideas. Agree, disagree? So, moving on to the how then. We have our equation sheet, and since we're talking about lengths, it probably behooves us to grab our equation that has lengths in it right there. All right, put that in. Paste it, there we go. And since we're talking about different frames of reference, to grab our Lorentz transformation. And from doing the example problems, recall that gamma is always greater than 1. Therefore, what's the relationship between L and L naught? Gamma is always greater than 1. L is larger than L naught? Well, let's try that. Let's say gamma was 2 and L naught was 10. Is 10 over 2 bigger than 10? Oh, our relationship didn't work then. How does, let's see, 10 over 2 is 5. How does 5 compare to 10? Less than. Oh, so L is always less than L naught. Oh, because you're dividing it by a number bigger than 1. Oh, that works that way. That's weird. Yeah.
Yeah, always bigger than 1.
Uh-huh. We went through that in the example problems. Because B is always greater than C. Therefore, the 1 minus that is always less than 1. Square root of something less than 1 is less than 1. 1 over something less than 1 is greater than 1. And for problems like this, I tend to think of gamma this way. Gamma, I rewrite it as 1 over the square root of 1 minus, and I group B over C together rather than keeping them separate. Because when they ask me for finding the velocity in terms of the speed of light, I think of finding the variable B, the relationship B over C. Because, you know, if I have, like, let's say I have that, I don't know, we'll put it in fingers, velocity equals 0.8 c. Well, V over c, for that, is 0.8. And then I don't forget, you know, that's just the way I tend to think about it, rather than having to plug in for c and everything like that. So, in this problem, they tell me that it starts off at 133 centimeters, ends up at 85, and then I want it square, which means that it's going to end up at 85.6 centimeters, because squares have sides that are equal lengths. Right? Cam, you got that, right? So, one of my lengths is 133 centimeters. The other one, what was that, 85.6? Which one's L, which one's L naught? L naught must be this one, and L must be this one because 133 is bigger than 85.6. And then just solve for B over C. Alright, let me give it a try, you give it a try, and if you need help, let me know. Alright, here we go, number 11. Right? We've got a neon sign flashing on and off every 4.6 seconds is measured by the head cook. I'm assuming the head cook is in the same frame of reference as the neon sign. Right? It's generated an asteroid spaceship moving towards Earth at this speed. Alright, so we know that when moving, time slows down. So, if in this one, if the astronaut is our observer, is the astronaut moving? No. The Earth is moving, right? So, in this, I would put the sign is moving in the astro frame of reference. So the astronaut is going to measure longer periods of time between flashes. Is that true? Or shorter? This is where time is always.
Are they moving fast? Yeah, they went.
The sign is moving towards them.
Oh, it's quite the astronaut.
No, not in the astronaut frame of reference. The sign is moving towards them. So the sign is moving. So he's going to see less time pass there. With what? With longer? Okay. Let's do it. Let's see if we get it. If not, we can always go back, right? Yeah. And this is all due to Yep. Heard that many times. I'm bored of writing it. All right. So, questions on the why? We're good? Excellent. All right. Let's go to the how then. Oh, yeah, I bet. And now, since I'm dealing with time, so I remember. Right? Since gamma is always greater than 1? Owen, yeah? Excellent. From my problem, I get 4.6 seconds. And we said that would be the shorter time. So that must be delta T naught. 0.83 C. V is 0.83 C. Yep. All right, give it a try. I'll give it a try also. All right? Let's see who gets there first.